Find the domain and range of each function, then answer the other questions. We have two functions today, starting with question number 1. We have the picture of a function given here, and we're asked to find the domain, find the range, and find 3 function values. So the first thing we do is find the domain. And when I look at the domain, I'm looking at how this function behaves in the x direction. And I see that it goes off to negative infinity. I see it goes off to positive infinity. And from negative infinity, the function comes all the way to this point here, which is 3. Then there's a gap where there's no function. And then the function starts again at 5. And so the domain will be negative infinity to 3 union 5 to infinity. Given this, that's basically this function exists everywhere except this window from 3 to 5. How about the range? Well, this function goes down to 1, 2, 3, 4 and a half on the y-axis. So this is 4.5 in the negative direction. And from here, it goes up. Never goes lower than this. And so the range would be negative 4.5 to infinity. And actually here, using set notation for your domain, these would be square brackets. The reason for that being that these are not open holes, and therefore this function does equal 3. X can equal 3 here, and x can equal 5 here. So these need to be square brackets. This can be a square bracket, and of course this is infinity, so it has to be round because you cannot equal infinity. Now, given a graph, find these 3 function values. F of 7, well, this is telling us x equals 7. So I go to x equals 7, which is here, and I look. And what do I have? Ta-da! A function value. Well, the function value is always going to be your y. So 1, 2, 3, 4. When x equals 7, y equals, ta-da, 4. Okay, how about f of 2? So we go to x equals 2. Here's x equals 2. And we look. And here's our function value. Where's our function value? Negative 4. 1, 2, 3, 4. So this will be negative 4. And f of negative 5. So I'm going to go to negative 5 on the x-axis. 1, 2, 3, 4, 5. There's negative 5. And I look, and where does this intersect my line? It just so happens to intersect my line at y equals 4. So if x equals this, y equals this. If x equals this, y equals that. Every time. Problem number 2. Slightly different looking problem. Very odd looking problem. Find the domain, find the range. Well, it goes to negative infinity in the x direction, so it goes that way. Goes to the left as far as it wants to. It comes to 1. There's an open circle. There's also a closed circle at 1, and then it keeps going to the right. But then going to the right, it stops at 2, 3, 4, 5, 6, 7, 8, 9. It actually stops at 9. There's no arrow point here. So what is the domain? It's negative infinity to 9. This is open and this is closed, so we put a nice little bracket there. What is the range? Well, the range, this goes as far south as it wants to. It goes as far in the negative y direction as it wants to because of this arrow point. But in the upward direction, it stops here. And on the y-axis, that would be 1, 2, 3, 4, 5, 6. That would be 6 on the y-axis. So our range would be negative infinity to 6. And again, because this is a closed circle, I can put a bracket. And we've been asked to find 3 things: f of 6, f of negative 7, and f of negative 1. So we'll start at f of 6. 1, 2, 3, 4, 5, 6. So there is 6 on the x-axis. When x is 6, find the y value. So we go up to here, and there's the point. When x is 6, y is 5. Okay? Find f of negative 7. So again, you come over here to negative 7, and you go down and say, well, where does this hit my line? Well, it hits right there. Where is that on the y-axis? And it's at 1, 2, 3, 4, 5, 6, negative 7 on the y-axis. So f of negative 7 is negative 7. What this means is when x is negative 7, the corresponding y value is also negative 7. Okay? Last one, f of negative 1. Well, you go to negative 1 on the x-axis. Here it is. And you see, well, this one's here and this one's here. You're going to use that one because this is an open circle, which means that graph does not exist at x equals negative 1. This graph is a closed circle, which means it does exist at x equals negative 1. And of course, at x equals negative 1, y is 0 because it's on the x-axis, so y is 0. So that's how you find function values and domain and range using graphs. If you have any questions, please come see me.